Okay, so we're gonna review section 2.1 and 2.2 through this exercise. This is at the end of the chapter 2 guided notebook. The commute times, it's the first question is about constructing a frequency distribution table. So we have 32 commute times. Construct a frequency distribution, a relative frequency distribution using 5 classes and a frequency histogram. Round relative frequency values to 3 decimal places. So I'd like it to help me out with this, guys. So first of all, let's find out the lowest and the largest value. What would be the lowest value here? So I can see 68 being the lowest, if you agree with me. And what's the largest? Can someone tell me what the largest value is?
I see a 67.
Oh, is there a 67 somewhere?
Yeah, it's near.
Yep, you are correct. Then I'll change it. And then largest value?
75.
75. Okay. Here's how you do it, guys. Just follow the steps and you will see. You will be able to create a frequency. I mean, online, when you do your homework, is gonna make you not just do the work, just like we're doing it right now. So let's do that. So now we need the class width, guys. Here's how you find the class width. You do the largest value minus the smallest value, and then divided by the number of classes. And he says 5 classes. So that's an 8 divided by 5, guys. It's a 1.6. And can someone tell me what we're gonna do with 1.6 now? We have to do something with it. Round it up. This is the class width. You have to round it up. So round up the class width to 2. And now here's how you construct the table. It's very easy. You put the lowest value, 67, and you start adding 2 this way. 69, 71, 73, and then 1, 2, 3, 4, 5, 75. I got an extra row, we don't need it. And then, can a student tell me what value goes in here? If this is 68, yeah, right before 69. And then I start adding 2 plus 2. And look, guys, this is from 67 to 68 inclusive. So how many values are there? 67 and 68, which is 2. Class width is 2. That is correct. So the class width, when you have the table, guys, if you want to find the class width, you take any 2 lower class limits, consecutive class limits, and then subtract them. You get the class width. 69 minus 67, that's a 2. 73 minus 71, that's a 2, and so on and so forth. Now the frequency, guys, figure out how many values are there between 67 and 68. So we're just gonna do that. 1, 2, 3, 4, 5, 6. For 69 and 70. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. For between 71 and 72, inclusive of 71 and 72. 1, 2, 3, 4, 5, 6, 7, 8, 9. 73 and 74. 1, Oh, there is one more 71. That's a 10 here. So 73. 1, 2, 3, 4. Uh, 75, 2. That is correct. So this is the frequency distribution table. Relative frequency distribution, guys, just take the 6 and divide it by the total. 6 is what percent, what fraction of the total. So just take 6 and divide it by 32. And 10 divided by 32. Another 10 divided by 32. 4 divided by 32. And 2 divided by 32. He wants the answers to 2 decimal places, so you just divide them and make sure to round your answer to 2 decimal places. And now what we have, what we call the relative frequency distribution table. Now, how do you construct the histogram, guys? First of all, you have to label the frequency right here. And this is the class. All right. And we need to go as high as 10. So if I were you guys, I will start at 0, then a 2, a 4, a 6, an 8, and then a 10, like this. Okay, the first one is 6. That's the first bar. The second one is 10. So I just have to go as high as 10. That's another 10. And then I have a 4. And then a 2. Usually online they are in blue, colored in blue. Now we need to put labels here for the bars. As I told you guys, the label will be halfway between 67 and 68. It's called the midpoint. What you do, you take 67 and add 68 and divide it by 2. So 67 plus 68 divided by 2, guys, will be 67.5. And then start adding 2, 69.5, 71.5, 73.5, and then 75.5. And what we have, what we call now a frequency histogram. Any questions, guys? Let me see if I have a question on stem and leaf plot here to just review it. Yeah, there is one. I'm trying to see if there is a question on the stem and leaf to do, because we reviewed, probably not, so we'll come later, you know, to this. So that was a review of section 2.1. While talking about the stem and leaf plot, let me ask a question here. If I ask you to read the values, there is a question online where he asks you to list all the values that you see in the stem and leaf plot. Before you list the values, guys, look at the key. The key says 7. Vertical line 2 means 72. So now you have to list the values like this: 65, 68, 72, 73, 73, 73, 73, 79, 81, 83, 83, 86, 87, 96, 99, 99. Now, there is another question where he says the key 7, vertical line 2 means 7.2. Many students did not read, that it means a decimal 7.2. And then when he asked him to list the values, they select 65, 68, 72, which is wrong. So if he says the key 7 with a vertical line 2 means 7.2, here's how you list the values: 6.5, 6.8, 7.2, 7.3, and so on and so forth. All right. So now let's continue with section 2.3. It's an easy section. You might have been familiar with this section from a previous exposure to the topic. We're going to talk about the averages: mean, median, and mode. These are called the measures of center. All of us know that the average, if I give you, if you take 4 exams and I tell you find the average of your exams, you will add up the 4 scores and divide them by 4. That's the average that you know of. But for your information, there are 3 averages. One is called the mean, one is called the median, and one is called the mode. Now, why do we need to do averages? For example, if I show you those scores in the class and I ask you, what do you think, just of the class? How is the class doing? It's going to be a little bit hard for you to tell just by looking, at the different scores. But if I can summarize, the scores for you, it will be easy to have an idea or form an idea of what's going on in the class. And that's why we need, to learn what we call the measures of center. There are 3 measures of center. One is called the mean, one is called the median, and one is called the mode. So 3 common measures of central tendency are the arithmetic mean, median, and mode. What is the mean? Let's define the mean first, which we already know what the mean is. The mean is the sum of the observations divided by the number of observations. We use this symbol for the mean. When you do the mean from a sample, we use this symbol, guys. It has a letter name. It's called X bar. And when we do the mean from a population, it has this symbol. And this is how you pronounce it, mu. This is X with the bar on top of it. And this is called the mu, a Greek letter. As I told you guys in the first meeting, that there are Greek letters that are introduced in statistics and used. This is one of them. It's an important one. But how do you find the mean is exactly the same thing. You add up the quantities and divide by the number of quantities. So we're going to start with this. Example, the following are salaries for 4 randomly selected employees at Microsoft. So this is a sample, guys, because at Microsoft, there are thousands and thousands of employees. So we only selected 4, and we want to find the mean. So how do you find the mean here? So you do this. And I would like as students to do this for us. 130,000 plus 135,000 plus 133,500 plus 136,000, and then divided by how many observations we have. 1, 2, 3, 4. That's how you find the mean. I'm sure this is something that's not unfamiliar to you. Can a student please find me the answer? Thank you. So that's the mean, guys. This is what we call the mean. Now, what's the median? The median is the value in the middle of the data set after you arrange your data from lowest to highest. So we're going to learn how to find the median. There's an example. We have the 4 salaries. So we need to arrange them, guys. We're going to put the 130,000 first. Then we're going to put the next lower one, which is 133,500. Then the next one, which is 135,000. then 136,000. You can mute yourself, guys, if you're not participating, so that doesn't come up in the recording. All right. Okay, where is the median, guys? Let me show you where the median is, the value in the middle. It's right here. You're going to see later that your TI-84 can do all of this. So I'm going to show you that in a second. So this is the median. Okay, any guess, guys? What do you think the median is going to be? It's like in the middle of between two values. So how do I figure it out? So I counted 1, 1, 1, 1. Median turns out to be right here. Do you guys know how to find the median between two values? What do I do?
Add the two middle
You add them
numbers.
up and divide by 2.
Yep, exactly. 133,500 plus 135,000 divided by 2. So if we do that, it will be 134,250. So the median doesn't have to be one of the values. It could be any value. So that's the value. But make sure, guys, to put the values in order. From lowest to largest, largest to lowest, it doesn't matter as long as you put them in order. So that's what the definition of the median is. All right. Let's tell you what the mode is. The mode is the value that occurs most frequently in a data set. So the value that repeats the most is called the mode. There can be more than one mode. It's okay to have more than one mode. And when no value is repeated, we say that there is no mode. So let's figure out what the mode is here. So can you see, guys, what the mode here, what's repeating the most? Uh, 84 is repeated 3 times. 86 is repeated 2 times. 82 is repeated 2 times. So it looks like 84. Okay. Now I have a question for you. Let's figure out the mean of this data set. I'm sorting the data already for your convenience. Okay, I have 9 values. If you have an odd number of values, guys, your median is one of the values. It must be one of the values, and this is how you figure it out. Cross one off here. One off, one off, one off, one off, one off, one off. There you go. That's the median. So which value, which position would that be? First, second, third, fourth, fifth. So if you have 9 values, it's the 5th one, guys. What about if you have 45 values? How would you figure out the location of the median? 45 observation. Does anyone know what position would that be? So you have 45 values listed here. How do I find the median without crossing one off from the right, one off from the left? Remember, here we have 9 values. The median turned out to be the 5th. From either side, 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. So if you have 45 values, does anyone know what the position of the median? Is it going to be the 15th value, the 17th, the 20th, the 21st, etc.? 23rd, and that is correct. And let me tell you how she figured it out. If you have an odd number of values, guys, 45, just add 1 to it. It will be 46 divided by 2. Once you divide it by 2, 46 divided by 2 will be 23. Count to 23, first, second, all the way to 23, and you'll get your median. Now, if you have an even number of values, guys, let's say you have 2, 3, 7, 10, 15, 18. 1, 2, 3, 4, 5, 6. We know the median, guys, is going to be right here between the third and the fourth, sorry. So the median is right here between the third and the fourth. Here's how you figure it out without even doing the work. You have 6 values divided by 2, which is 3. Your median is between the third and the next one, which is the fourth. So 7 plus 10 divided by 2. I put those notes already in the guided notebook about the median. So your calculator, the good news is your calculator can perform the mean and the median easily. Once you input the data into the calculator, you can get the mean and the median. Now, this is very important example, guys, and you're gonna come across questions like that online. We have 3 measures of center: mean, median, and mode. The question, which one should be using? Does it matter which one we use when we wanna talk about the average? Yes, it does matter. And you have to be very careful of which measure to use depending on the situation. So I'm going to give you this situation, guys, and I'd like it to help me out to understand the difference between the mean and the median mainly. Let's say you live in a small neighborhood, of a street block that has 5 homes. And these are the values of the homes. One is $70,000. One is $72,000. Another one is $75,000. One with $73,000. And the 5th house is built on a triple lot. It's worth $850,000. Okay, let's find the mean and let's find the median. Mean will be 70,000 plus 72,000, guys, plus 75,000. And I appreciate it if a student can do the work for me, 850,000. And once you're done, guys, you must divide by 5. So I'm gonna pause for a second for you to do this for me. Okay, now the median. It's easier for the median. We're gonna list them. So I'm gonna put 72,000 first, 73,000, 75,000. Oh, there's 70,000, I'm sorry. 72, 73, 75,000. And then 850,000. And to find the median, it's this value. Okay. Let me show you this scenario, guys. And people can do that. They can mislead people using this scenario, and nobody can tell them that you're doing anything illegal or so. Let's say a realtor wants to sell a house in this neighborhood. He can make this statement. He can say that the average price in this neighborhood is about $225,000, but you're getting a bargain on the house for $75,000. Where did he come up with the $225,000? It's the mean. So he's advertising that the average price of the house is and he's right. The mean is $228,000. So he can say that the average price of a house in this neighborhood is $228,000, but he's selling this house here for 75,000. That's and if I hear this, a house that's worth $250,000, I'm gonna get it for 75,000. But people will rush, you know, just into buying this house. But if he was an honest realtor, he should not be making this statement. He should not be using the mean at all. In this scenario, guys, the mean is a bad number to represent the average. Can you tell me why the mean turns out to be bad? It's not good to use it to find the average price of a house, of a home in this neighborhood. Why is that? Although it's an average, but in this case, particular case, we should refrain from using the mean. Why? And instead, we should be using the median. Look what the median is as an average. The median is 73,000. The realtor should say, the average price of a home in this neighborhood is about 73,000, and I'm selling this house for 75 or 73, whatever. That's good, but this is bad to use the mean. Does anyone notice why the mean turned out to be very inflated here? Yeah, that is correct, Aaron. Because there is one house that costs a lot more than the others. This is called an extreme value, and extreme values do impact the mean, guys. It's called an outlier. An outlier doesn't belong to the data set. It's like all in the 70s, and all of a sudden I get hit by with a mansion right here that's worth $1 million. This is 850,000. So in the presence, guys, of extreme values, you should refrain from using the mean, but instead you should use the median instead. Spec, yeah, I noticed the screen froze for a second. All right, so if they give you a data set, guys, and they put a very, very large value or very, very small value that doesn't seem to belong to the data set, and I'll ask you, which measure should you use to represent the average? You should say the median. The median is a better measure in the presence of extreme values. An extreme value is a value that is very, very large or very, very small. In this case, guys, I put a very large values. So a better measure here will be the median. If the realtor wants to be honest, you know, just in his business, he should use the median instead of the mean. Nobody can get him in trouble because he's not making anything up. That's the mean, but we should not try to use it. Okay. So let's go through this summary of the mean, median, and mode. Okay. For what type of data, guys, the mode is the only one that we should be using. We cannot use the mean and the median. What type of data we cannot do mean? Remember, mean and median, you have to add and subtract, add and divide numbers. So where do we don't do that? For what type of data? Yes. For example, if I give you this, I ask you what's your favorite color, and you give me those answers. Okay. You give me those answers. I cannot find the mean and the median here, guys, because these are not numbers. I cannot sort those numbers in order or add them up and divide by the number. But I can find the mode. The mode is the value that occurs most often. What's the value that occurs most frequently right here? What would that be, guys?
Blue.
Blue. So you can find for qualitative data. For qualitative data, the mode is the only one that makes sense. For quantitative data, you should always find the mean or the median. We don't usually use the mode a lot. If there are outliers in the data, what did I say is preferred, the mean or the median?
Median.
Median, exactly. Median is preferred over the mean, as the mean can be misleading when outliers is. If there are no outliers, guys, use the mean. The mean is the best. Okay. Now let me show you, although this is not, I'm not going to be asking you questions in the homework about the weighted mean, but I would like you to be aware of it so you can understand how your grade is determined, guys. So weighted mean. In this class, your grade is determined from the following sources: 20% from exam 1, 20% from exam 2, 25% from the final exam, 15% from lab, 15% from homework. Well, there is no lab, final exam, homework, 20%. Let me change this. And project is 15%. Let's do that, a project. If you end up with the following scores, how do I find your total final grade, guys? So let me show you how do I find your final grade. I said your exam 1 is 20%. So how do you find your average grade at the very end? Your exam 1 is worth 20% of the grade. So what I do, guys, I just take your score from exam 1, which is 84, and multiply by 20%. I change 20% to a decimal, which is 0.2. So I'll multiply 0.2 times 84. Then for exam 2, I said it's worth 20%. So I'll do the same thing. I'll multiply it with 0.2 times 75. Your final exam is 72, and I said it's worth 25%. So I'll take the 25% and multiply by 72. Your homework is worth 20% of the grade, and you got 100. So you just do 0.20 times 100. This is how my stat lab grade book works. This is how we'll determine the grade at the very end. And then a project is 15%. You know that we're making this up. This is not how your grade is determined, but that's an example. So we just do 0.15 times 85. And what do you do, guys? Can someone tell me what do I do once I find the scores to figure out your final grade? What do I do with those values, 1, 2, 3, 4, 5? I add them. So 20% of 84 is what, guys? 16.8. 20% of 75 is 15. 25% of 72 is 18. 20% of 100 is 20. And 15% of 85 is 12.75. And your weighted average is this. Just add them up. So can a student please add them up for me? Just give me the final grade. So that is 31.8, 41, 49.8, 69.8, 79, 82.55, which is a B. If 80 up to 90 is a B, so that would be how, this is how I determine, guys, the final grade in the class. It's all done in Excel or in the grade book of my stat lab, but just to give you an idea how this works. Any questions here? Okay. When we draw histograms, guys, I'm going to show you some 4 shapes that we should be aware with for histograms, very popular shapes. And actually the most popular one is going to be this one. Look at this histogram, guys. It looks, they call it symmetric histogram or symmetric distribution of data. Why do we call it symmetric? Because as you notice, guys, through this line here, you can see the half on the left-hand side reflected on the reflects the half on the right-hand side. So this acts like a mirror. So when a curve that looks like a bell-shaped, just like this, bell-shaped, we call it symmetric. And the mean and the median and the mode in a symmetric distribution, guys, are exactly the same. They are all the same value. The median is the value in the middle. The mean is the average, and the mode is the value that occurs most often, which is the tallest bar. That will give you the tallest bar, will give you the value that occurs most often. And this is where are all located. So in a symmetric curve, the mean, median, and mode are exactly the same. So that's symmetric. Remember that. This one is called uniform. All the bars have the same height. Look, all the bars have the height of 20. 1 repeats 20 times, 2 repeats 20 times, 3 repeats 20 times, 4 repeats 20 times. In this case, we call the distribution uniform. The mean and the mode are exactly the same. They are in the center, but there is no mode here because every single value repeats 20 times. So you don't say that there is a mode because they are all repeated the same number of times. Now, let me show you the third graph. You can see, guys, that there is a tail toward the left here. Look at the tail going toward the left. And this is called a skewed left distribution. So any histogram that looks like this and that looks like there is a tail toward the left, we call it a skewed left distribution. Now, the mean, the mode is where the tallest bar is. So the mode is right here. There are some questions in the book where he labels 3 letters, A, B, C, on the number line and asks you which one is the mode, which one is the median, and which one is the mean. For the mode, guys, is easy. You look for the tallest bar, and then you can read the letter right under there. Whatever the letter is, that would be the mode. Now, how do you figure out the mean and the median? I'm going to give you this trick, guys, and please remember, I put some notes right here. In a skewed left distribution, the mean is always closer to the tail than the median. So if you guys have 2 dots here, one of them is the mean and one of them is the median. How can you tell which one is the mean? The one that is closer to the tail is the mean. So it's going to be this one right here, the mean, and the other one will be the median. So if we go to this one, it's the same thing again, guys. This is right skewed curve. Look at the tail, it's going toward the right. The mode is going to be right here, right here. This is the tallest bar, so that would be the mode. Now for the mean and the median, guys, if I put 2 dots here and I ask you which one is the mean and which one is the median, you say that the mean always is closer to the tail. So then that one must be the mean because that's the tail right here. And the mean is, this one should be the mean. And then the remaining value, guys, will be the median. And this is how you can tell. So the mean will always fall. I put the note here in the direction in which the distribution is skewed. Okay. Any questions here? The most common shape, guys, that you will be learning in statistics is this shape. Most data sets, guys, when we graph them, they will turn out, when we do a histogram, they will turn out to be like this. Bell, they call it bell-shaped, just like a bell right here. And this is what the symmetric distribution is. Okay. So this is section 2.3. I'm going to do a new video for 2.4.